So I will start now describing what we are going to do these 3 hours. And if someone enters, then I'll try to get him up. Okay, there is another participant that's entered right now. So the idea today is we have only 3 hours. So the idea is really just have a brief start on some of the things that we have in the book about using shell script. So to download data from biomedical repositories and then do some processing. The idea here is not to tell you how to everything about shell script. It's just an introduction. How can you use some of these tools to do some relevant tasks that we normally do every day? And also, the idea is not for you to know any kind of programming or any kind of IT knowledge. We just go with these examples, and you will see that it's very easy to do these automatic stuffs, just knowing a few commands in shell scripting. So I will start by asking you for all of you to start at this page, so 44. So if anyone doesn't have this this PDF or otherwise, please download it as soon as possible. It's the one that I send you in email. And then you should have now a shell script with this content. So I'll just use here, I'm just using Emacs, but you can use any other kind of text editor. And from the last section, we developed a script, a very simple script that provides an echo, a print. So an echo, it's a command in shell script that does a print, and that prints just prints a URL. In this case for ABI, to get all the proteins related to a given compound. And the main thing that I hope you understood is that we have this variable here, the $1, that is like a parameter that we give to the script. When we run, it will replace by the value that we give in the terminal. So the terminal is something like this. So you should have something like this in your computer. It's a terminal where you can add your commands, and it should use a folder that you can then see the files and so on and so forth. So the idea is that I hope that everyone now can do something like this, like just calling getproteins.sh, and then give any kind of parameters. I will just give by a chemical compound, for instance, this one, and this will print the URL. Okay, so this is just a very first script that was explained before. So if anyone has any problem with that or didn't understand any of the things that was described in the book before, please let me know, okay? Because I will start this tutorial with the first question, so we can start this this tutorial, everyone in the same level. I will just start here a question, and I want you to copy and paste the command, run it, and the result will be on your screen, and you just have to select the right answer there. So I believe that we have some new participants here, but I will explain how, if anyone has any question about the previous sections, please let me know, okay? So I will start the poll. Let just start it. So the question is, what is the output of the command? And then I write the command. This is a compound, I believe it's a popular one nowadays, is chloroquine. and it will get the proteins about for that compound and count the number of lines. Okay, we will do it afterwards, but it's just to check if you get all the same result. So if you have any problem in copy and pasting, please let me know. So I'll do it also in my screen, but not clicking enter, so no one sees my. So you just have to do this and then press enter. So I don't have any answers yet. Are you seeing the poll? Okay, so Manuel told me thanks. So please let me know also when you select the answer, because until now I don't have any results yet. Okay, I have one. Great. So the Xargs command and curl command that I'm using here, I will explain today. So the idea is that you have the get proteins working, and then the Xargs and the curl will see how it works. So I have just 2 votes. Please let me know if you are having any kind of problems. EBI was a little slow, the web services, so since we are using this live from the URL, some of you probably are still waiting the results. So I have, Annalisa just received the instructions, so I'll try to catch up. Okay. Do you have the get proteins.sh on your computer? If not, the first step is just to create this file get proteins.sh and copy and paste this echo command here that is in the book. Is the last part of the previous section. So just copy and paste this to a file and it should be working. Manuel said that this 372, no, there is a problem in there. Do you have the get proteins, this one that just prints one compound? You can try without the Xargs, just to see if it just this comment with the number to see if this is the link that is returning. I still only have 2 votes, so but they are correct. So we have 2 votes, but they are correct. So I assume that some of you are getting the right answer. Some of you are getting 372. I don't know how you get that number. Can you check if you have this free 72 number? Can you check if you run get proteins with this number 3638 and you get the same URL as here? Okay. Okay, if you have an error in the unspecified website within the, probably that's an error in the get proteins .sh. Okay, check if you really have. Mainly the problem, you can copy and paste. Probably the best thing is copy and paste your content to here. Okay, to the discussion forum, so I can see it if there is a problem, but should be normally the problem is you don't have the $1 or you have a new line in the middle. Okay, we are that's a problem. So you see that here Annalisa Milano is copying and paste the URL, and there is a problem here. It's the Y, and you see that in the book there is no Y, there is a new line. So be careful in copy and paste. You have to copy first the first line, then the second line. So otherwise you will copy the new line. Okay. Manuel said, so I'll try. Okay, so we already have some votes here. I'll just end the poll. So I believe everyone is already tried. So I'll run. So it's 22, as you can see. So if you are not getting this 22, probably it's a copy paste. Okay, I will show you how you have this problem. So if I copy all of this, I will just copy and paste to the new line. You see that it prints here new lines, and I have to remove them. In some cases, if you are using Windows, it sometimes also adds you an Y. So you have to delete this. All this link has to be in the same line. Okay. To be easier, I'll just copy insert, because you will have the same problem here. I'll try to see, I'll type the message here. So try to copy here from this shot. I don't know if you have the same problem with the new lines. So I'll just clean this up. So sorry for all of you that already have this 22 result and want to get 4 in the tutorial, but this is just trying to get everyone in the same step, because this is common problems. So everyone is having any kind of problems. Otherwise, I'll just, if no one posts anything in the discussion forum, I will just go and start to explain curl. Okay, I'll go and start to explain curl commands. If you in the way have any kind of problem, please let me know. So what we did with the previous section was just using a command to print the URL that give us all the proteins related to a given compound. But if we just printing the URL in the screen is something that is not very useful. So the idea that we want, and the exercise here in the book is about getting all the proteins, all the information from a given compound. So we wanted to download all this information automatically. So here in the data retrieval, so I have the screen here showing the first section. We can do copy and paste the URL and the command curl, that is a client uniform resource locator. That is a command that is available in everywhere in other in language like Python, in PHP, and it's mainly what does what your browser does. You give a URL and it gets information for you. The main difference here is that we are now using the shell script, and we can automate all this process. So if we copy and paste, and I will just use here the text editor to clean the new spaces. So I will just copy these commands and paste it here. As you see, I will clean the new lines. And I will just now copy this curl all in the same line. Okay, I will just click on enter. EVI, it's a little slow, probably too many users today with the tutorials. But we will see all the proteins related. You can see, you can go and see all these proteins are related to our chemical compound. So in this case, caffeine. Okay, so this is just to see how curl works. So you just add a URL and it gets the information for you. But using just this command with the unique URL, probably it's useful, but mainly what we want is to have a script that we can use curl with different compounds. And to do that, we can use this command here that is the same as before. The only difference is now that we have the chemical compound as a parameter. By the way, I just keep this. If you don't have the curl command installed, you can also use wget, but it's the same thing. So if we now, and you see that now in the book there is a difference. If you have $, here is to just to put this command directly on the terminal and execute it. If there is a number here, is to add it to our script. So I will just copy and paste this command here. Now I'm going to the get proteins.sh. I will just put this as a comment and add the new command. Don't forget to clean the new lines. And I just save the get proteins a script, and then I just have to run it. To run it is here, so I just have to invoke it again, now with the same chemical compound, so related to caffeine. I just copy and paste. This one I can do it directly, and just now I can click on, press on enter, and I have all the proteins in there. So at this time we already have a script that, given any kind of chemical compound, just with a cabbie identifier, I can get on my computer all this list of proteins and their information. And this is can be used for any chemical compound. So if you now replace the chemical identifier by this one, so just removing this number and adding a new one, you will get another list of proteins. In this case, this ID is for carbon monoxide, so we will get an even longer list of proteins. Okay. So this is a little slow because EBI now it's a little so slow getting you the information, but it will come, and it's a longer list of proteins. As we wait for the proteins to arrive, okay, they are here. You see, you can go in your terminal and go up and see all the information in there, but you can also use the less command. So less command is a command that helps you paginate the results. So you can see each page at each time. So it's very useful when you just want to see the results and you want to search for something, or you want to go up and down when you have a long list. So I'll just copy and paste. So it's the same command as before, but now we have a pipe and a less. So the pipe in shell scripting is very useful. Is the result, so the output of this of executing this command here will go as input for the next command. So less will use all these proteins as input, and you will see that now we have the information that curl gives you, that is trying to download all this information. And if we wait a while, it will give you the proteins. But until we wait for the results, okay, it's here. So you can see that now I can scroll up and scroll down. So you can use the up and down arrows, and also page up and page down. Okay. You can also search the document. So for instance, if you want to search for a given protein, you just press the backslash, and for instance, search for caffeine or ryanodine, and it will give you the lines where this protein is. Okay. When you are finished with analyzing the results, you just press the Q and you get out. Okay. So just press Q. Okay. Any question till now? Okay. So, but okay, analyzing all of this in the screen is very useful, but okay, we can do it on the browser. It's much better to use it on the browser. So what is really the advantage of using all this command line? The advantage is that we can automate this, and one of the things for automating all this is to create automatically the files with the information. So I can create these CSV files. So CSV files are command separated values that we can open then in our spreadsheet tool, like Excel or OpenOffice. So now doing the same, I will do just the same command, but now I redirect the results. So this is redirecting the results to a file, and you can give you the name of the file, you can give whatever you want. I will just paste it here. So we still have to wait for the results, but in the end, we will have all the proteins in that file. So I have a question here. I cannot type the backslash when I'm in less. Normally in my keyboard, just shift and the number 7. That is the backslash. Probably it's a problem with the keyboard. There is. So let us see now the results. So we can use less to see if it created our file. So you can see that we can use less and scroll down the results. Okay. Or we can use our text editor. For instance, I can open now the KB because it's a file and see all the proteins in my text editor. Okay, so, and you can open in your spreadsheet tool also. Um, so now we are able to get, this is already a useful script. So we give a chemical compound, an identifier, and it returns all my list of proteins to a file. The problem here is sometimes it's useful, sometimes it's not. It displays some information, as you see here, about the download time, upload, total spent, so on and so forth. So why this appears on my screen and does not appear in the file, since I said to redirect all the results to the file? Because these terminals, these scripts use two channels to print the results. One is the standard output, the other is the standard, it's the error output, the standard error output. And we can use both. So it's like having two screens where we can put some information in one screen and put some information in another screen. If we don't say anything, everything goes to the same screen. So the standard output and error output goes to the same place. But since I said to redirect the results, when I said to redirect the results, I said only the standard output. If I want to redirect the error output, I have to add the number 2. That is the standard error output. And here, if I'm just saying to send it to devnull. Devnull means a file that does not exist and goes to Orwellian, so it does not exist, and it's like ignoring it. So I'll just have it here. I will just run again. Sorry. So I'll just copy and paste. So just copy and paste this, and then adding also this part here where I say I don't want to see anything in my screen. So now everything went directly to the file and nothing was shown to in my screen. Okay. We can also do this without having the worry about standard error output and standard output, and just use the parameter in curl that is -s, and it means that it's silent. So if I have here s, I save it, and then I just run it without this application. Sorry, I will just clean this. So without this, and I have to run it again. I just have to copy and paste again because it lost the dots. Okay. So now I'll just run it again, and you'll see that the file is being created, but nothing is being shown in my computer because I had this silent option. Okay. So this is again to see the results, and you can see, of course, in LibreOffice or Excel. Okay, so if we have this file in our computer, we completed the first step, that is downloading data to our computer in an automatic way. And of course, you can, this is an exercise you can get for water and cold compounds, the protein. But now we will go in some data processing, some first steps in data processing. So we have the proteins, but we want to filter somehow these proteins. And one way to do this is to use this grep command. This grep command is very useful because it's like a filter. Okay, we have a file and we want just the lines, grep filter lines, just the lines that match a given pattern. Okay, we give a pattern and it tries to match those lines with a given pattern. As you saw previously, so here, if we use the less for the file that we downloaded, all of these proteins have their session number, the name, and in the third column, we have some information about the relation between the compound and this protein. And imagine that since we are in the exercise of the book, we are trying to see some diseases related with caffeine, we are just interested in proteins that have as relation something that we don't know, miscellaneous, disruption phenotype, or disease. Okay, so let's start with this miscellaneous and see if we now get all the proteins with this pattern. So for doing this, I'll just copy and paste here and CSV. And you can see that just by using, I'll just clean the screen because it's better for you to see. So the idea is that instead of just showing all the proteins that I downloaded, now it only shows the proteins that have as the third column the label miscellaneous. So in the sense, we filter all the results that we want. So in the sense, we are starting to process our data. But like I said, we don't just want the proteins related with this label. We want the proteins related with those three labels. Okay, this one. So we want to add disruption, phenotype, and disease. For doing this grep also can accept multiple patterns. So, and this can be done by using the minus expression. So we have one expression, the second expression, and the third expression. So I will just copy and paste this. And then the second line. And then the file. Okay, and now you can see that we have some proteins that are related with this as a disease, some disease and miscellaneous, some as disruption phenotype. So we were able to filter the list of proteins for the ones that we really wanted to study. So now if you want to do all of this in an automated way, we can add all these commands to our script. So our script, the first step is to download the proteins. Now we can add the second step, that is filtering the lines that we want. How we do this? We have here one special thing, that is the pipe and the /. That means that we are redirecting in a way the result of the command curl to as input to the command grep. So we are using the pipe. This character here means that the rest of the command is in the second line. This is just for not having a full line with all the commands, and it's almost unreadable for humans. So we just need to have this to our script. Okay. And don't forget to remove the new lines, and I will just save. And then we just need to run it. Let me check it out. So now I'll just run this script, and as you can see now, it downloads the information and it filters the information that I asked. Okay. So, and of course, like we did before, we also can redirect this information to a given file. So if I now copy and paste this file name, but you can give the file name that you want, and then just redirect to this file name, and it gets you the results. Okay, it's just waiting for getting the results. Okay, so any questions until now? No, everyone comfortable? Okay, so the results should be here, and we can do the less to the KB uniprot now relevant, and you get the all the proteins that have those labels. Okay. Okay, so grep is to filter lines, but this is a CSV file, so it's like a spreadsheet. And if we want to process also not just the lines, but the columns, we need to use another command. So, and one that is very useful and very powerful, and in this book, I just give some examples of what we can do with this command, that is the walk command. gwalk is an implementation of walk that is normally available, and it does a lot of stuff, but one of the things that is very relevant is to enable us to process lines as a data element. So we can, in a sense, split the line using a given character. So what I'm saying here, for instance, in this example, I'm just using as field separator. So the -f means that I'm using as field separator the comma character. Why comma? Because I'm using comma separated values, a file that has all the elements separated by a comma. And then the useful thing is that I can just get the elements that I want. And here $1 means that it's the first column. Okay, so let us try this example. So if I just add gwalk and then use as input for this gwalk, so you see that I'm using the minus sign, and I give him the file that we downloaded before. So we will have just the first column. And the first column is the session numbers. Okay, the session number. So I have the list of the proteins that are related to caffeine, that are related through this disease or disruption phenotype or miscellaneous. And I have now all the proteins, the session numbers in the same place. Okay, so just for trying, this is what I want, because the next step is downloading information about the protein. So this the other part is just here some examples, and you can try, because we can deal with multiple columns at the same time. So the example there is the same, where I can now, for instance, if you want to skip the first column there, sorry, just having to copy and paste this again so you can see better. So here you see, I'll just copy and paste here. And you can see that I get the first column, then a comma, then a space, and then the third column of that file. And you can use different values. For instance, you can use here, you can add X, A, whatever you want. Okay. I have a problem with the scroll. I'll just just have, probably I have to open again. Okay. So any question? No. So I'll just add now the GWalk to our script like we did before. So I'll just copy and paste here to our script. Don't forget to add the pipe and the sign that tells the script that the rest of the command is in the next line. Okay. So I just save this file, and now if I just get the proteins, I just copy and paste it here. And I forgot the dot. And this is now saving to the file, just waiting a little bit. Okay, I have some questions here from Eva. Do the field separator need to go inside quotation marks? Are you asking me in here? Here, okay, probably you are asking this part here, right? So this is a string that you can put wherever you want. Okay, so you can have A, B, C, and D. But for the GWalk, since this is a command print, to know that it's a string, you have to enclose it with quotation marks. Okay, but this is not the field separated. This is one that I created, just an example. The field separator is specified here with the option -F. Is that okay, Eva? Okay, just for you to see the result again. So relevant, now we have the file that is relevant, and then identifiers, this is the name I gave. And now I have just only the accession numbers for all those proteins. Okay. Okay, so now we are going to talk about task repetition. Any questions until this part? Because this is one of the most important parts of shell scripting, because most of the times when you start to learn a programming language, you have problems with you have to learn how to create a loop and so on. And now people think that in shell scripting you cannot do these multiple applications of the same command without learning how to create a loop. But this is not the case. We have a command that is xargs that is very useful without all the worry of creating loops to apply the same command multiple times. Okay, and it's about task repetition. So because all of this is very useful to download the proteins, to filter the proteins, but normally we don't have just one command or one task to do. We want to do the same thing multiple times. Okay, if no one has any question, I'll go forward explaining this kind of task repetition. So the idea is that, okay, for every accession number that I have in that file, just let me show you here again. So relevant identifiers. So for all of these session numbers here, if I was doing this manually, I will just copy and paste each session number and create a link like this. And using this link, I will get the XML file for each protein with all the information. But we don't want to do that. We want to automate this process. So we want to create a script that not only creates the link based on the session number, but then for each session number goes and gets the information from me. And for doing that, we can do it with an assembly line. And the idea of the assembly line is that I will explain here is applying the xargs command line tool. How it works is very simple. So the xargs receives as input a list of proteins in this case, but it's just a file with lines, and it applies the same commands to each line of the file that it receives as input. So what I'm doing here is just cat and the name of the file. So cat and the name of the file is the same as less, but without, so just put in here. So it's the same as less, just having, but without the pagination. So it just prints the output to the screen. But then I'm not just putting the information on the screen. I'm using the pipe to redirect the output to the xargs command. And what it does is apply the same command to each line that we have in here. How xargs do this is first we can specify as a mark, as something that we can then use it to refer as the value that was received in that line. That varies in each line. So normally we use these brackets, okay, but you can use other kind of characters. But when I use these brackets here, I'm saying, okay, every time I say in the following command that I use these brackets, I'm referring to the value that I received as input in the line. So in here, I'm just creating an echo command that will print another protein ID. And you can see that we have the squares here. The squares here means that the input I'm looking at right now. So if I have an assemble line, is like which row, which part I'm working on in now. Okay, so I have a line and I work each piece at each time, and this is the piece that I'm looking at this moment. So if I just now copy and paste this, so I start with the same as I did before, so just the cat and the name of the file, then I do the pipe, and then I just, sorry, I will just close the terminal and open it again, because the pagination is not working correctly. So just let me put it here. Just 1 second. I'll just go to the right folder. Okay. So let's start. Okay. So I have the cat command, and then I have now to copy and paste this xargs command after the pipe, and I'm just missing the final part of the string. It can be anything. Okay, so I just have it here. So, and what we will do is apply to each element of the file, it will apply the echo. Okay, so it will print all these accession numbers inside the string I gave. Okay, let's see some questions here. So we can use less instead of cat. No, in this case you can't, because if you have this, less is just for the human to see. Okay, so less is, let me just do it as an example. So if I just use less, I can go up and go down. In this case, it's just one page, but I can search. So it doesn't give as output the list of files. Okay, and cat, and this is not the goal here. Cat is just used to open the content of the file and give as input to the xargs. Okay. So let's just work on the previous command here, and this is something that I can change. So I can just have another, and have this separated by another 2, and just have retrieve. So you can do whatever you want, okay? And it will replace the session number that I'm seeing at the moment, okay? So this is just for learning about xargs, because it's doing nothing useful, it's just printing the session numbers again. But the first step that we wanted to do, as you remember, is creating these links, okay, the XML links to get the information for each protein. And we can do this automatically. So we use the same cat. I will just reuse here. So it's the same as before, but now we just print our echo. It's the URL that corresponds to the information to each protein. Here I had the problem because I copy and paste with a new line, and I just wanted to copy and paste without the new line. Okay. So if I just press enter, now I have all the links for each protein information. Okay. So I have all these links. So now, okay, I have all these links, but if I don't do anything more, what I have to do is to go for each one of these and apply the curl command, okay? But I want also the script to do it automatically. So how can I do it? I just need to replace echo by curl, okay? If I just replace echo by curl, it will download the information for that protein. But here I have a small problem, because as you know, curl downloads the information and puts it on the screen. We can test it. It will take a little time, but we can test it. So as you can see, he's getting all the information for each protein, but he's printing on the screen, okay? And something that, okay, you can then redirect all the results and look at each protein, but it's in the same file. But one good thing is to have the information for each protein in a separate file. And for doing that, we can have here, just let me clean this. We can have the curl with the link, but then add this option that gives the name of the file where I want to put the content. And so if I have add this to the curl command, it will, for each link, it will create a CABI file named as CABI and the name of the compound. And then you can see that here the bracket means that it will place the name of the protein. Okay, so we will have a file, XML file for each protein. So let us try. I believe there is a problem somewhere. Let me see. Okay. So we can see now that if he gets all the information from these files, and you can see that he created all these files. We can check just the size, the right size, and see one of these files. For instance, let us see this file here. Sorry, this one is not here. Downloaded just. So for instance, we have this protein here. Okay, so the XML file. Okay, so let me see, because some of the files, some of the URLs, you didn't get it. So probably some of the URLs you didn't get it right. Just let me check. Probably it's the HTTPS. So let's see if we have now the, nope. Some of them have moved. So some of the proteins didn't download. I have to check. Sometimes they change the URL. Let me see. They got it. Okay. Something that is not working for some of the points. I don't know why. I have to check afterwards. Okay, but we still have all these files here. Some of them are not downloaded correctly. Why? Because we have 0 bytes in here. Okay. So one of the things we can do in case of these problems, I have to check what happened, but not, so we cannot stop this tutorial. I have the files in an archive. So if you have, probably you, when I send it to the email, I send it also a link to the archive with all the files. Okay. So if you have these archive files, you can copy now the KB and the name of the compound and every XML to your home directory. Okay. Because some of the XMLs didn't download it, I don't know why. Okay. So you should see something like this. Okay. So any question? For the links, I will check afterwards if it is anything has changed in the link, and I will let you know. Okay. So one thing if I want to check if everything is okay, is to check the first line of each XML file. And to check the first line of each XML file is to do the add -n1. That means that I just want the first lines, the top lines, using add, and then the parameter n let me specify the numbers of lines that I want. And in this case, I just want the first one. So if I just have this command and apply to all the XML files in there, I see that I have all all of them are files with XML. Okay. Any question? No. No. Okay. So going forward, so now we can apply this to our script. So the script is using curl, grep, and geoawk, and now we can add the xargs and curl to our script. So if we had this here, just the pipe, checking that the rest of the command is the next line, just cleaning the new lines. Okay. Just cleaning everything. Okay, so we now have the script not only downloading from scratch the proteins, then filtering the right proteins, that getting the right column, and then downloading all the XML files for each protein. Okay. So if we apply all of this again, and I can do it, but it will take a little time because it will apply all the previous comments, okay, before processing XML, before going to process XML. I can try it. I can remove, so I will just apply a remove to all XML files, then I can copy again. So now I don't have any XML files in my directory, and I'll just apply the command with the caffeine identifier, and let this wait. Now it will get all the information. Sorry, I didn't save it, so it was using the previous version. It just printed these session numbers. Okay, it will give you the same errors for some of the proteins that I have to check the URL. Okay, so let me see. We can apply again the add XML file and see how many. No file was downloaded this time. I have one problem here. Probably it's this line. Just sorry, because I forgot to tell you one thing that I didn't say before. So this didn't work very well. Why? Because I just created files without the identifier. Okay, you can see that the KB files are KB underscore, and then I don't have the identifier of the chemical compound. Why this happens? Because I forgot to add these two lines. Because I didn't created a variable that I named ID. This variable is useful because now I have multiple commands, and the $1 changes the interpretation in these commands, because as you saw, the key walk also uses the $1 argument, and I want to differ between $1 as a column and $1 as ID. So the best thing to do is to use a variable and say, okay, ID is equal to $1. That will be equal to our CAB identifier. And then I just need to remove also this. I did manually before, but I can do it again and add it here. You can see that these two lines don't have the pipe at the end because they are separated comments. They are independent from the others. Okay, I just save. Let's see if it now works. Now it works correctly. So it's downloading. Some of them are still having an error in the SSL. So let's see. Okay, so for the ones it downloaded correctly, as you can see. Okay, so most of the proteins we have it here, and they are correct. Okay, any questions before going to XML processing? No questions. So one thing we can do now, I can just go directly to the XML processing. I was just waiting if anyone tried this. Okay. So going to XML processing. So what we did before was processing with grep and GeoWalk. We processed text files in terms of the lines and the columns, because they are CSV CSV files, so they are comma separated values, so we could filter the lines and the columns. Okay, but we didn't download the CSV files from Uniprot for each protein. We downloaded the XML files. The XML files, as you can see, are much more complicated. I have one question here about identifiers. Sometimes they are used $ID and sometimes not. What is the difference? So let's, as here, the identifier, I used ID because now I just created this variable that is equal, so it will contain the value that I give as parameter. So when I just use this command here, I just invoke this script, and then I give this ID as parameter. And what I did in the script was adding this $1 that is equal to this to like giving you him a new name. Okay. Okay, so it's about the quotations. Okay, so okay. Sometimes with quotations, sometimes not. The problem is that if you have here in these two places here, we don't have the comments because they are file names. Okay, so they are just like a command. But the other, let me see if we have another one with the commas. No, we don't have it. But if you have something like this, I will write here. If we have something like this, okay, what it does is it creates a string and it replaces the value of the ID for that string. Okay, if you just have single quotes like this is previously in the book, it will just print ID without replacing ID for the value that it contains. Did I answer your question, Teresa? Okay, all right. Hope so. Okay. So if you miss some of these steps or you have any questions, probably we'll have some time in the end to address some of these individual problems. Okay, so don't worry. Okay, so about XML files. So like I was saying, we have these XML files. I will show it here. All of them that I downloaded. I have these ones that I downloaded incorrectly. By the way, I can teach you how to remove them. So I just remove all of them that have 2 underscores, and I just remove them. So I just see the files. So you can see that I have all these XML files that I downloaded, the proteins for which I got the XML file. And let us see just one example. For instance, this one here. So to see the contents, I use less. Okay, and you see that all the information that you see on the Uniprot webpage about this protein is in here. Okay, you see that the session number is here, the full name, the short name, alternative names, and I'm just paging down taxon, publications, the authors of those publications, everything. I'll just go to the bottom of to the end of the file. You see the amount of information, and in the end, we have the sequence. Okay. So, and all of this information is organized as XML, and XML has this information organized between using these elements. So I use the minus, and XML uses the minus and the the greater sign and the to enclose some data elements. Like we are seeing here for the sequence, it says, okay, I have this element here that is the sequence, have these properties, so length of the sequence, the mass of the sequence, so on and so forth. Then it ends the here, as you can see, this ends the description of the element, and then you have the value for that element. So we have the sequence, the content of that element. And then when it ends in XML, you have the end label, and you have here saying that the sequence is over, and I can start another one. This is a hierarchical organization, so the sequence is inside an entry element, so this is like a tree, okay? And you can see that this entry in the beginning of the file, so I just went to the beginning, you see that this file, this XML file, starts with an entry element. So the entry is all the information we have about the protein. So, for instance, we can still use our grep to find information about this XML file. So if I just copy and paste this grep here, I will try to find any XML file that I downloaded that have that contains a protein that is related to Homo sapiens. So it has that line in the file. As you can see, there are some description here from the XML files that I have here. This was the errors that I had in downloading the files. Probably there is a HTTP error that in a few hours it will work. But okay, we found the proteins that have Homo sapiens in the XML. So if we are just looking for proteins that are related to Homo sapiens, we don't want to study other proteins that are not for Homo sapiens. We can get information just by doing a grep. Okay. And as you can see, we have two types of information in our screen about the grep we did. We have the name of the file where that expression is, and we have also the expression that was found in the file. So we have this here in two different colors, this information. But the second one in our example, it's workable because we don't need this information, because the information we already have, we were looking for Homo sapiens and it has the Homo sapiens. What we want is the name of the files. One option that grep has is to just print not the pattern that he found in the file, but just the name of the file. And this is the -L here. And if we have now the -L word command, we just have now the name of the files. So if our goal is to download information about all the proteins related to capping, and then filter out only the proteins that have information about Homo sapiens, proteins that are related to Homo sapiens, then we can do this grep and get this name of file. But as you read in the book, the main goal is to find the documents, the publications that are related with these proteins, that describe these proteins, or are mentioned are cited in UniProt about this protein. And this information is also in the XML file, like I showed before. So the XML file have an element that is the DB reference that says that is of type PubMed, and this references gives the PubMed ID that describes this protein somehow. To get all these PubMed IDs, we just have to find in a given file. Just come in here. So I just press enter, and you have all the PubMed IDs. So a long list. We can do the less commands and see. You can see that we start with the same PubMed IDs. They didn't change, and we have all these articles to read, okay, and to get information. So one way now to get the PubMed IDs, okay, we have all the line that was matched with this grep, but what we want really is the ID, this number here, okay? How we can do this, we already know. We can use the key walk command. So we just need to replace this less and add this key walk. The key walk, now you can see that key walk is used to filter the columns of a given line, and you can say, okay, but those lines are not comma separated, but we can use any field separator. And if we look at the number here, it is enclosed by these double quotes. And if we imagine that these double quotes are field delimiters, you can see that this represents the first column, this represents the second column, this represents the third column, and the number, the PubMed identifier, is the fourth column. So using the QWalk command to get the identifiers, it's very easy because we define the field separator as double quotes. We have to use the backslash, so the double quotes are not used as a string. And then the print command of QWalk, and just use $4 to print the fourth column of that file. So if I just press enter, you see that I got all the identifiers from that list. Okay, so now I have, from a given file, I got all the PubMed identifiers. Okay, any question? No? Okay. So this is okay, great to use for a single file, but because we tested this just for this protein. Okay, we did it this step just using one protein. But of course, we want to do this for every protein. And to do this for every protein, we have to use, like we did before, the xargs. So we want to do this grep, searching for the PubMed, to every KB file that we downloaded the XML file. So we can now concatenate the grep that we did it before. Let's just go back and see that we have here a grep. Probably I'm not finding that out. Just grep. So this one. So I just did the same thing, just the grep to find all the files that are related to Homo sapiens, the proteins. With these files here, now I can pass it to xargs. So I just add the pipe and pass the result to xargs, and the xargs will do the grep, trying to figure out where are the, sorry, because I passed it Okay, I have to paste line by line, where I just prep trying to find the PubMed identifiers. If I just apply this, what I get is just all the lines that match uh, the PubMed in those three files. So let me recap. So I just find the files and then apply the grep. These are all the PubMed identifiers on those three files. Now, mounting everything, so I just need to add the keywalk that we did before to find the right column, so to get only the identifier. And doing this, we are doing all these three steps. So we are filtering the proteins that are about human Homo sapiens, and then we are filtering from those files the lines that have the PubMed identifier, and then we have just getting the column with that value. Okay, uh, and you have all these results. Okay, but now we have a problem, but because we are filtering these lines from multiple files, from three files. So if we do a sort, so if we sort the results, and for sorting the results, we can use also the command sort using the pipe. So all these numbers will go to this command and it will um, order them. So you can see that some of them are repeated. I have one question here. Sorry, I didn't catch it before, but can you use whatever you want after the Xarks option, or only would work? Thanks. So the question here is, let me go before just this question. Evie is asking me if I can add a given value here, like, let me see, at, and if I have at here, it will work the same. Okay, it is the same thing. This is just, normally we use these brackets, but it can be anything. Okay, and then after this is the command. I don't know if I answered your question, Eva. Okay. So the sort command, like I told you, it gives you the same PubMed identifiers. You see that this list contains repeated PubMed identifiers. Why this happens? Anyone has a clue about this? So I can drink some water. I will have this question. You can answer in the discussion forum. So the reason why we have this duplicates, we are getting these PubMed identifiers from three different files. Okay, I will just recap. So I just get free proteins. So this is free proteins, and then I just extract from these free proteins the PubMed identifiers. Exactly. So the answer here from Joseph is correct. Thank you. Is that we have the same publication in different projects. Okay, this is expected. So this is the reason why we have all these duplicated entries, and sometimes even in the same XML file we also have this duplication. So we have to remove them. Otherwise, if we apply this without removing it, we are applying multiple times the same thing, which is just losing time. So one of the things that we can do is, we can remove all of these duplicates, is just using sort, because sort has an option that we can add minus U, and then this option here removes all these duplicates for us, so we don't have to do nothing. It just removes all the duplicates for us. Okay, so having this, this is what I tried. We can check how many duplicates we have, and to do that we use another command that is WC, that is word count, and I just have here apply the pipe and then write word count, and you can see that I have here 3 values. So the values that WC show us is the number of lines, the number of words, and the number of characters. Okay, so you can see that the number of lines is the same as the number of words, because in each line we only have one word, the number. Okay, the PubMed identifier, and the number of characters in this case is not very interesting. So why we are using this? Because to see how many duplicates we have, we just have to sort count with the -U option and without the -U option, and we have this difference. So we removed almost half of the identifiers. In the book is different because we have that problem with the downloading. I'll try later on, probably it's something temporary. But as you can see, we removed almost half, like in here, of the PubMed identifiers. You can try also, as a curiosity, if you really want to use the command line for everything. Sometimes it's useful. For instance, you can also use it to do some calculation and see how much is, how many of the PubMed identifiers we filter out. It was 99. Okay. Joseph just asked here an important question. It's about using WC. So going back, we can have another option that is -L. It is explained before, afterwards, sorry, but of course there is an option to filter out, instead of these 3 colors, just the number of lines. Okay, and in this case it will be better. So let us try with -L. It gives you just the number of lines. Okay, and put it here. Okay, thank you for the question. This is normally WC is used when we want to use the number of lines, like we did in the question, in the poll in the beginning of this tutorial. Okay, so we can now create a new script that is getPublications.sh, and this get publications is to run afterwards. So we run first the get proteins, and then using all these XML files, we apply this to get the publication. So it's a second step script. So to create a new script, I just create a new file. I will get the name, so get publications.sh. I will just copy and paste everything there and explain it. So I have to clean it now, and as I clean it, I will explain. So the first thing is just the first line is just to have the ID that I give as input, like we did before. Then we have the grep, just filtering out the files that are related to Homo sapiens. I just have to put everything in the same line. Then I have the xargs. Okay, so xargs that applies the grep to all the files. And then I have the grep, sorry, the keywalk to get just the numbers, and the sort to remove the duplicate. So I just save it. For everyone that didn't remember how to have this script running, we have to do just a change on the permissions so it can run. So we have to do change mode that changes the permission, and I'm giving just the user, that is you, permission. So the plus sign is to give permissions to execute to this file that I created. So get publication. So I just run this, and then I can just run get publications for the caffeine compounds. And as you can see, as expected, I get the same numbers as I had before. So I just created a script that now runs with any chemical compound after I run the get entries, of course, the get proteins. Okay, now that I get all this med IDs, I can also, just to check it out, I can use also the WC to see if everything is okay. And as you see, we get the same 100 PubMed identifiers. Okay. If we don't have any questions, okay, everyone is comfortable with the script. So we have the get proteins and the get publications script. Okay, so now we will change to a different way to deal with this XML files. This is a very simplistic way that we did it before, was just using the same commands that we did with text files, just using grep and keywalk, and figure out how we could get the information from there. But we can use more advanced things, and one that is very easy to use is using the shishpath. Shishpath is like telling the tool where is the element in the XML file that I wanted to extract. And since the XML file is a tree-oriented, organized file where the elements are organized as a tree, normally I say this, that we can see an XML file like a book, okay, where we have chapters, and inside the chapters we have the section, and inside the section we have the paragraph. So a shishpath is like saying, I want all the third paragraphs of the sections that are named like this. Okay, so I state the structure where the element is in. But for starting to use shishpath, we need a new command, and there are multiple commands that we can use for applying shishpath, but one that is very, very simple and it's available everywhere also is XML int. And this command, you just give a shishpath, the XML file, and it gives you the elements that match that shishpath. So in our case, we have a little problem with these XML files from Uniprot. So if we see, for instance, let me see this file with the less commands. So let me just have it here. So you can see that this XML file starts by describing these namespaces. Okay, these namespaces are ways to tell us, to identify, to disambiguate all the terms that are inside the document, because all of them are related to these namespaces. So if I click on these links, I can see what they represent, because they are, when I say something inside this file, I'm referring to uniprot namespace. Okay, why this is a problem? Why? Because XML linked doesn't work very well with these namespaces. We have really to specify each time we want something from a local XML file that we are trying to get that element as a local name. I don't want to give all the link to each of the of the of each time I want to filter out from the file. For instance, uh, in this example, I want all the elements in the Excel file that are referenced. And for doing that, I have explicitly to say that I have trying to filter out the elements referenced. So like imagine the book is like all the sections that are named reference. And I need explicitly to say that this is a local name. So this is not to use the link uniprot. This is just a filter to see where reference is inside the file. So the problem here is that I always have to state this to get the information. Just let try to see the result. Sorry, wrong. Copy paste. Just the name of the file. And you can see that we have the reference element. So all the contents inside the reference. This is the last one. So this is 78. So all the information that is between the beginning of the reference and the end of the reference element. So inside of that, we have the citation, the title, the authors, the DOI, the PubMed ID. Okay, we have 78 of them. Okay. So SysPath works very well because I got all the reference with a local name. Something that I couldn't do with the grep because the grep filters lines, and here with the SysPath we are filtering sections of the XML. So we are getting pieces of the XML just saying the section that I want. Okay, and one trick not to use all the local names and to do SysPaths that are much easier to understand, we can do a trick that is, okay, let's get the top element and forget the local name. So you remember that when I just opened the XML file, the top element was entry. Okay, every element was inside the entry. If you go to the end of the file, so the end of the file, we have all the information inside the entry. And you can see that the copyright, if you want the copyright, okay, but we just needed the information inside the entry. So we can use a trick that, okay, let's use SysPath to get the element entry. Let's copy and paste here and the name of the file. So before redirecting the result to another place, to another file, just check what is showing. So I'll just do the less, and you see that he removed the top lines of the XML files and the last ones also. You see now that this output ends in the entry L. So in this trick was mainly to remove the name spaces problem. So they were removed from the file, from the XML element. So I just copy and paste, sorry, just having the XML. And now I just redirected the entry element to this file that is named the same. I just added underscore entry. So just removing the other one that I did it by mistake. That's just this. Okay. Probably didn't create. Okay. So let's do a list of this file. So it's um, now the entry. So you can see that now this XML file starts with the entry and not with the namespace. Okay, this is the difference. So if I remove this, you see that the original file has the XML and the namespace. Okay, this was done, like I said, to remove the obligation of using all these local names in the sheet path. So now everything is much easier because now I just uh, can apply the sheet path without referring to local name. So let's try this same query as before. I can go backwards here so you can see the difference. So you can see that now I can remove all of this and just look for reference, but I have to change it to the entry file that I created, and now I have the same result. Okay, what was the difference? The difference is I don't have to state the local name. Okay, and probably I'm just using reference, but you notice that I'm using also these backslashes and what they mean. So what they mean is, in this case, when I use two backslashes together, I'm saying that this reference section can be everywhere. Okay, it's like saying I want a section in the book that is named reference, and it can be everywhere in the book. Okay, I don't give the tree, the path to reach to this reference. So when it gets everywhere, it gets an element named reference, it gets the result. Okay. So we have different operators in SysPath, and you can look at some books that I specialize in SysPath and get all this information. But I just listed some of the most popular ones. So like I said, if you have these two backslashes and then the element, it will give you all the elements that have this element. Let us try. So, and to try all of this, you just need to write the query here. So the SysPath query. So DB reference. So I'll just get it. You see that it goes directly to the XML file and get all the PubMed identifiers. Okay, so the same thing we did with the grep, but now more in a more robust way, because we are really asking for the name of the section. Okay, so, and you can see that I can go up. We have not only the PubMed, but we have also the UniProt, other UniProt information and other references besides PubMed ID. So all the DB references that are in the file. Okay. So another option is not using the two backslashes and saying, okay, I really want something that is in the entry element. Okay, for doing that, I just use the backslash saying, okay, this is the top element, and then the DB reference can be everywhere inside the entry. Okay, but since the entry is the top element, the result will be the same. And I can also specify the full path to reach that section in the XML file. So I can copy and paste, for instance, the entry reference citation DB reference, and this is the right places. So it gives you the same results, but now you are explicitly saying that you want something that is in the entry, in the reference, and then inside citation, and then the DB reference. Okay. So if you have any question about this, please let me know. Then we can also have ask for child's elements of DB reference, okay? Sections that are under the section DB reference. And for doing that, we can use the star. So just, you can have this star here, and this is the same, but so I'll just do it as it is in there. And you get, these are elements that are under the DB reference. So they are properties, in this case, entry names, match status, so on and so forth. And then you can, I just, you don't want all those elements, but you just want the first one, the first property element for that reference. And for doing that, you just have to write property, for instance, and say, okay, I just need to look at the first one, just like me. And this is the first element property that is under a DB reference. Okay, this is the same for second, the same for the third, and so on and so forth. Another thing that is also very useful is not to get all the information, but just some of the attributes. For instance, if you see the property here, it has some, the element has some properties that are defined. So this property is about molecular type, and the value is genomic DNA. So if you just want information about the type of the property, you can use the at and then the name of that property there. So let me just try here. So I just need to add the at type, and you have all the types defined for the proteins. Okay, so you can do the same for the value. So you can come here and do the same for the value and get all the values. But sometimes you want to filter out, like in grep, I don't want every type, I just want types that are related to protein sequence ID. I just want the sequence IDs. And for doing that, I just need to filter. And to do the filter, I just use the square brackets. So square brackets, and then the name of the, let me see if I type it correctly, sequence ID. Okay. Just let me change this. Okay. And then I get all the elements that have as type protein sequence ID. And you can see I have the value there. Okay. Another option is also to get the value. So if I just want the value that is shown here, if I want all the sequence IDs, now I just need to add the value. And then I have all the sequence IDs from my XML file. And if I want to get the sequence, it's very easy. So in using grep is hard, because if you use grep, the sequence is multiple lines. But if you use the shishpath, you can come here and just type sequence, sorry, and use the option text that gives you the value inside the sequence element, and it gives you the sequence for you. So if you want to extract all the sequence from the XML files, you just need to apply this shishpath. Okay. So this is what we did before. So now we can, any question? So if you have doubts about Shishpath and want to learn more about Shishpath, there are links on the book that gives you all the syntax. Okay, but this is the most popular things that you can do. Okay, so all of this we try this Shishpath results and queries to try to find different things on the file. And now, as an example, we can do the same thing as we did before with the Shizax and Kiwok in here in the script, doing without the using the grep and the giwok command, but instead using the XML Shishpath. Okay, so let me just stop this. No. I was trying to clean out this blue thing here, but I couldn't. Uh, okay. Um, so now let's to see if to get the PubMed IDs. We can see that we saw it before that the DB reference contains all the PubMed IDs that we wanted to check. So we have here one example that we did before. We see that all the PubMed IDs are under inside this element, but some of them are not related to PubMed ID. So if we really want just the PubMed IDs, we need to say a filter with the square brackets. I need just with the type PubMed ID, and then I just want the value of the ID. So if I just add this, sorry, DB reference. One thing I have to change is the quote for single quotes, and that's it. Okay, so now I have in each line, I have the identifiers for the PubMed. So the same thing I had mainly with grep. So if I now want just the number that is inside the commas, I can also use the GWalk, the same way we did it before. So we just need to filter out by using GWalk. So I say that the field separator is the double quotes. So the number here is inside the double quote. So the field separator is double quotes. And then we just want to print the second column. So the second column, why? Because this is the first column and this is the second one. And if I have this, I just get the number. I have here one specific thing from GWalk. I can do a filter before if I want just the lines where there is at least one field separator. Because sometimes the Shishpath gives you empty lines without any values in there, and in this case I just remove them from the output. Okay, so this is the same way, is an alternative to what we did here. So if we wanted to replace the grep and the GWalk by the Shishpath, the result will be just the same. Okay. Any question? Okay. So about text retrieval. So now we have, until now we started from the chemical compound identifier. We got the the first step was to get the session numbers of the proteins, and from the session numbers of the proteins we got the XML files, and from the XML files we filter out the ones that are about human, and then got the PubMed identifiers on those files. So now the last step that we need to apply is to get the text. So our main idea is to get text uh, from the publications that are related to the proteins that are related to our chemical compound, in our case, caffeine. To do that, we can also get that information from this link from Uniprot, where we have the PubMed ID and then .rdf, and I get the information about that publication. Let's try. So I'll just copy and paste here. So I will just apply curl. You can do in your browser also. Let me see, because I have a problem in here. This one is not working. Okay. There is some problems on the net. I don't know why. Sometimes it works, sometimes it doesn't work. But you have to try multiple times. So let's do it again. Okay. So as you can see, you have the information about that publication with this PubMed identifier in RDF. RDF, it's a data organization, but is also using the same syntax as XML. So we can apply the same thing that we did before for XML using this RDF file. So you can see that we have the title here, and we have also the abstract here, okay, inside the comment element. And these are the two elements that we are looking for. So we want to extract information from text about diseases related to the chemical compound. And so we need to retrieve this text automatically from this URL. Okay, so we apply the same things as before. So we have here the get publications.sh, and now we can apply this curl, but using the xargs. Okay, so this is, remember, this is number of lines. So I just need to add a new line, this one, with the same idea as we had it before. That is, apply this code command to all the PubMed IDs. This is the same idea that we did for protein. So we want to get all the RDF files for each PubMed ID and save it as KB, the ID of the compound, and then the PubMed ID RDF. Okay, so I just copy and paste the xargs. I just have to say that, okay, this is a part and the rest of the command is the next line. I just need to save it, and let's hope that there will not be many errors in the web service. Okay, so let's try and get. Okay, it's getting all the text from those PubMed identifiers that we searched before. As you can see, it takes a little bit of time because it's getting all the publications. Some of them are having errors, but so we have to retry multiple times. As you saw in the previous example, I tried the first time, it didn't work, but then the second one, it worked. Sometimes we have these problems in the internet, but it's getting most of the documents. Okay, so you can see that now we have to check, we can use all this command to check how many files we have. So you can see that we got a lot of files publications related to the proteins. We can count how many, and we have 81. Probably we lost 20, so we have to run again to get the ones that have an error. But we will go further with this 81. Probably in a few minutes it will get the next one. And as an alternative, if you don't want to use the service from UniProt, there are also alternatives using the PubMed web service. And here you have the link. It's the same thing. You just need to replace the link in there. Okay. So for instance, we can try this one. We have time, so I can copy and paste just to see that it's the same thing. So you just copy the link for using the utils from PubMed and retrieve the information in XML file. Okay, and you have the information now in XML about the publication. Okay. So if you replace this link here in the script by this one, you get the same information. So, okay, we have multiple documents, but we just need to get the title and the comment. So for instance, if we see the contents of a given file, let's see if this one was downloaded. So you see that this is contains a lot of information about the publication, but mainly what we want is just the title and the abstract, so we can extract information. So you can see that we have the title here and we have the abstract here. So one way to get this information is using the grep command that we already know. And for doing that, we just need to find the lines that have the title and the comment. Just copying one line each time. So having two patterns, finding the title and the comments, that means the abstract in that file. That is 135. And as you can see, he extracted just the two lines from the file that contains the title and the abstract. Okay, the same problem we have here. We don't know, we don't want to extract information from inside the XML labels, so we want to get rid of them. So one way to get rid of them, as you already know, if we want to process columns, we use GWalk. And now we are using GWalk with two field separators. So we are using both the greater and less signs to remove, to split the line in multiple columns. As you can see, if we use these two characters as field separators, we have title in the first column, because this is the 0, so this is a column without any value, then the first field separator, then the first column, and then first, then title is the second, and then we have the third column with the value that we want. That's the reason why we use here the third column to print. So let's try it out. So we just use GWalk, then field separator. I'll just write it down. So field separators, when I use square brackets, I'm saying any of these characters inside the square brackets can be a field separator. And then I just print the third column. And then I get the output is really the text describing that protein, okay, that we now have available to process. Okay, so now we can also create another script. So we have the first script is get proteins, that gets all the proteins related to a chemical compound. Then we have this get publications that retrieves all the publications related to those proteins. And now we will create a new one that is get text, that will get the final result, that is all the text related to that chemical compound. So let's just create a file named getText, text.sh. So I'll just copy and paste here, and then I will explain what we are doing. Okay. So the first thing is the same thing. So having a variable with a name ID, and then doing the grep that we did before, now applied to every RDF that we have in our folder, and then applying the key walk to just filter out the text inside the title and the abstract. So save it. So just changing mode to the user, giving permissions to execute, and we have get text. Now it's ready to run, get text, and we can apply with the same chemical compound. So every script that we are doing today can be applied to any chemical compound, right? So and multiple chemical compounds. So let's try with less so we can see all the text. So you can see that now we have all the texts, all that information about the chemical compound that we were looking for. Okay, I'll just go down, page down. You see all this information that we had to process. Of course, we can also store this information in a file, and for doing that we just redirect, and by redirecting now everything is inside the KB text file, so everything is here. Okay. So we are reaching the end of this this tutorial. We have plenty of time. And just a preview of what is explained next in the book is about disease recognition. So after we have all this information in here, what we need to do is to find diseases in this text. So of course you can read, this is already a very good application. So you just give a chemical compound and you get all the text, but then you need to read all the text to see if you find something interesting. But for instance, if you already know that you are trying to find something about malignant hyperthermia, you can just make a grep in all this text, like you do in Word, just copy and paste, and it gets you can do a less, and it gives you all the sentence here. It's better because you see that the malignant hyperthermia is highlighted. So you can see that you have the abstracts and titles where you have a reference to this disease. So if you are interested in finding more information about malignant hyperthermia and its correlation with the chemical compound, this is a way to do it. So we have here a question: how can we add a new line character after every publication? The last example obtained with get text. How can we add a new line character? Okay, so if I understand correctly, you want to split this sentence in in a different line. Is that correct, Teresa? Publication mark plus new line plus publication. Okay, you just wanted to add a grep in here. Since we are applying the grep directly, you can't, okay, because grep applies to every file here. But we can apply the args, okay, and then you do each grep each time, and then you can add the the echo plus new line, or you can write to a file that is named kbid and then dot text. For instance, we can get the same. Let me see the example here. So let's do this exercise here. Let me see the example we have here before, like this. So we can do one thing we can do is to so I'll just change the script, okay? So you just first see which files you have. Okay, and then apply the arg. And then you apply here the grep to that file. Okay. And to add, sorry, because I'm doing this at the first, so, and you want to add this, all of this. So the best thing is to have this in a new script. I will just create a new script, okay? Just let me, I'll just have a new get text file.sh and give as parameter this. And create a new get text file.sh, and here we have the same information as there. So I'm doing this live. I'm trying to explain. Let's see if this works in the end, but it's the same thing. So ID, then what I need to do is a grep to the file that I received, then get the keylock, and then echo something like a new line. So I will just put this so we can see better that is separated, okay? But you can have the new line here. Okay, so let's see if everything, so it's here. Let's see if this works, okay. Okay, this one, this is just one file, okay, then creates. Let's see if this works, get text, receives, and gets. Let's see, this is on live, so probably it will have some errors. Get text and the number 907732. Okay, I didn't save the script. Important thing, get text text file .sh. I need to change mode to get text file. Okay. I need to call the other application. Sorry. So I need this. This is a script. Okay. So I didn't put I didn't put the new line, but you can add it because here is better to see. Let me. You can see that I added this line with equal characters, and the way I did it is the same way. I just split it, the script, so it's better. It's easier to understand. So this get text, just apply, see which of the files I have, the RDF files that I downloaded for that compound, and then applies for each one, because now I need to do it each one each time, because the previous script applied the grep to all the files. So I created the easiest way. Sometimes when we want to apply multiple commands for the same Xargs is to create a new script, and the get text file for that, for each of the RDF, what it does, let me go here, it just now applies the grep individual to that file here, to this file, and then apply the gwalk like we did before just to this file, and then just add some characters like the new line. Is that what you wanted, Teresa? I can add the new line if you want. It's in here. If you search, for new line, the new line cannot be added with gwalk. Inside gwalk, yes, probably you can. Yes, probably it's more complicated because then you need to understand gwalk. Okay, but probably you can also, because gwalk, it's a language. It's a programming. It's almost a programming language. You can do everything inside gwalk. But normally, I just use gwalk to do these simple things, because then, if you want to do something more complicated, it's better to use a programming language like Python or other one. Okay. And using these same techniques, Xargs, gwalk, grep, simple, you can do almost everything. Okay. You can. I was looking here because you have echo. I don't know if it is in the beginning or in the end, but if you want to have the new line, you in echo, you have to use the minus expression. So he evaluates the expression, otherwise it just prints text slash and. So you need to use the single quotes. Okay, and now let's try again. So you can see that now I have reprinted the echo. That's strange. Let's minus. It's not using the echo. It prints the. Let me just try that without the minus a. Okay, you don't need the minus a in this term. But you can see that now you have a new line separating each file. Okay, so I just went forward. So we were just finalizing our tutorial, and now with a new line, but it's the same thing. You can create your file KB hyperthermia that contains all the information about hyperthermia, and sorry, wrong copy paste. So we can create this file. you can see that Kevin hyperthermia has all the information with a new one. Okay, so if you want more information, you have the links here, and we don't have the time in this tutorial to go further, but I can give you some ideas. The idea to apply text mining and to do some more advanced things with each text, we need to have more powerful tools to search for the mentions of diseases in here. And the first thing we have in the next section is the regular expressions. So grep can also apply regular expression to text, and this gives us a lot of power to find different mentions of the disease. And we also, the first step that we normally have to take, so all of this is about the regular expressions, and this is all of this is example based content. So you just try and using this example and you will see the results. So it's very easy to understand. And then you have the tokenization. This is the first step to do it, and you also can do it with shell script commands if you just want to split the abstract in different lines. Because one problem we have here is that, as you can see, the abstract, the same line, has multiple sentences, and if we want to split each sentence per line, we have to apply some processing here and then explain how we can do it. And then we can apply some entity recognition and see where in the text we have this reference to the disease. And in the end, we have we can find these diseases and the relationships between different entities in the text. So this is chapter 4, and chapter 5 is okay. If we want to search for any kind of diseases, we can use ontologies, and for using ontologies, we also use everything with shell script commands. So like using curl to download these ontologies, the OWL version, and then we have all these techniques to get information from these files. And in the end, we can create a dictionary, a lexicon with all the diseases and apply grep to find all the mentions in the text for those diseases. Okay, so in the end, the result will be not only the diseases but also the ancestors of those diseases. So in the end, you can create your own lexicon with all these diseases and get the information from there. So you can see that. Let me go to the end. But the output of applying then the grep to all the sentences that we downloaded. The main difference here is that it's tokenized. We have a lexicon of all diseases, and we get all the diseases that are related with caffeine done in an automated way. Okay, and mainly that's it. And then you have all of this in many tools. Any more questions? Any question? Anything that we have half an hour, so sorry if I was too quick. If you want me to explain anything in detail that we saw before, or even if you didn't you weren't able to put the scripts working, please let me know. I can try to help you. So I believe everyone had all the things working. So if there are no more questions, probably we can finish this session. I thank all of you to be present for your participation and for your questions. And please let me know if you have any questions even afterwards the tutorial about shell scripting and all the things that are in the book are always uh, glad to help. Okay, so thank you very much, and see you one of these days. Okay, thanks.